So far we had to use Espressif's tools to use Bluetooth on the ESP32. Today I will try it with the Arduino IDE. I'm curious how it will work. Maybe you come with me on this discovery tour. For sure we will learn a lot about how Bluetooth Low Energy or BLE works. Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode around sensors and microcontrollers. In this video we will cover the basics of Bluetooth Low Energy, the different roles of devices, how we debug BLE connections using our smartphone. We will build a notifier and a client. We will try to fake a Polar H7 heart rate monitor, at least the BLE part. If we have time, we will have a look at an iTag chain finder and a Xiaomi Flower care system. And maybe we will discover some secret sauces necessary for a delicious BLE meal. A lot to do, let's start. Bluetooth Low Energy is a variant of Bluetooth. It is a different standard than the Bluetooth we use to transmit music to our earphones. Its primary application is short-distance, low-energy transmission of data. Like Wi-Fi, it operates in the 2.4 GHz band and therefore needs only short antennas. BLE has many features and today we will just scratch the surface. In BLE there are two sorts of devices, servers and clients. The server is the provider of data and it has to advertise its existence. The client only scans the channels and listens to incoming calls. Fortunately, our ESP32 can be configured as a server or as a client. We just have to change the sketch. The next important things in BLE are universally unique IDs or UUIDs. For the moment, let's just define that UUIDs are long cryptic numbers. Each server offers services. For example, the heart rate monitor, not as a surprise, provides a heart rate service. And the weight scale offers a weight measurement service. So far so good and not too complicated. And even better, these services are standardized. This enables our apps on our smartphones to connect to all heart rate sensors if they expose the standardized service. All these services are numbered. Here is the list where you can see all these services mentioned before, including the assigned number. You will find a link in the description pointing to this list. It is also possible to create other services not contained in this list, as we will see later on. Then of course the definition is manufacturer specific. Next, each service offers one or more characteristics. If we stay with our heart rate monitor, this service can provide the following characteristics: heart rate measurement, body sensor location, and heart rate control point. Only the heart rate measurement is mandatory, the others are optional. But where are these characteristics defined? Also here we have a list of possible characteristics from A like age to W like weight. And also here we can set additional manufacturer-specific characteristics. Each characteristic, as each service, has an assigned number. Enough theory for the moment. Let's go hands-on. This is not easy because we always need two devices to do the test, a server and a client. Fortunately, our modern smartphones support BLE. As our ESP32, they can act as a server or as a client. For our purposes, we need an app which helps us during our first tests. I tried a few of them. The only which is useful is the NRF Connect app from Nordic. It is available for Android and iOS. And the best, it is free. So we have our working BLE debugger. Indispensable. I read that you can also use Linux system to do the same, but was not successful with my Raspberry. Maybe a more successful viewer can help me here. As a first step, I want to fake the BLE part of the Polar H7 chest band. If we want to fake something, we have to hack it first. And here comes the tricky part, to make sure that my heart rate monitor stays alive and sends some signals. Because it only works if I have some sweat on my skin. This becomes probably the most tiring video I ever produced. I have to run up the stairs every few minutes to show you the results of the chest band. Some people might inject that this is healthy for an old nerd like me. Enough complained. Here is the result. In Scanner, we see all BLE servers around my phone and especially the Polar H7 chest band. In this case, the smartphone is the client and the chest band the server. If we connect our smartphone to the chest band, we see its characteristics. As expected, it exposes the heart rate and the body sensor location. If we tap the 3 downwards arrows, we see my heart rate and, if I run, how it moves up and down. And here it is a good time for a digression towards the properties of characteristics. There are a bunch of properties to select from. And if we look at the heart rate characteristics, we see that most properties are excluded, which means not allowed. The only permitted property is notify, which means that the server notifies at regular intervals if its value has changed. In this case, my heart rate sensor informs every second about the new pulse rate. The client only has to listen and to display the result. So our Polar sensor has a heart rate service which exposes 3 characteristics. One of them is the measurement itself, which has the property of notify. Knowing this hierarchy is essential if you want to work with BLE. The chest band has even more services like the device information service. It has a lot of characteristics like the hardware revision, etc. All these characteristics are read-only. This means the client has to initiate a read if it is interested in the result. So let's build a notifying server using our ESP32 board. Here I have to thank Neil Colban for his work. Because Espressif did not deliver a BLE library for the Arduino IDE, he developed one. Fortunately, it is now included in the standard distribution and we do not have to install it separately. It also includes some examples. We choose the notify example and upload it without any changes to an ESP32 and open serial. The ESP acts now as a server which is eager to notify somebody. To save energy, it waits for some interested parties before it starts to transmit. Like that, only the receiver is on. With our smartphone, we can signal our ESP32 that we are interested in its values. We do this by connecting to the My ESP32 device in the BLE app. Our ESP32 immediately starts to send notifications. My phone shows an unknown service. And if we have a closer look, we see that the characteristic has 4 different properties: read, write, notify, and indicate. If we hit the 3 down arrows on our smartphone, we see the value counting up. We established our first BLE connection with our ESP32 and got some data from it. Cool! Now we have to dig a little more into the matter. The unknown service has a complicated UUID and the unknown characteristic too. If we go back to our sketch, we see the same 2 strings as service_UUID and as characteristic_UUID. If we go down the sketch, we see that we need to perform 2 things in setup. First, we have to create a service, and second, a characteristic for this service. We use the 2 UUIDs from before, and in the characteristic definition, we also meet our friends from before: read, write, notify, and indicate. So we should know all to create our fake heart rate monitor. If you remember, we need a service with the number 18OD and a characteristic with the UUID 2A37. And this characteristic should only have the property notify. But wait, which UUID do we have to use for the service and the characteristic? The UUIDs were much longer, right? Here comes the first secret sauce. We can build these UUIDs if we add this string to the assigned numbers. Fortunately, this string is always the same. Don't ask me where it comes from. It is here and it's always the same. That has to be sufficient for us unless a knowledgeable viewer will tell us more. We insert our two UUIDs to the service and the characteristic and upload the sketch again to the ESP32. If we go now to NRF Connect, we see our heart rate monitor with the characteristic measurement. And if we press Notify Us, we see the heart rate values coming from our ESP32. This was easy. But does it really work? Let's check it with the Polar watch. Unfortunately, it does not work. The clock does not recognize our nicely built fake. So sad. I think we need a second secret sauce. This time I do not know it. Maybe you know it and can help me. So we have no other choice. We have to move on with our discovery. I quickly add the sensor location as a second characteristic by adding its UUID and an additional characteristic definition. I delete all unnecessary properties and voila, we have the two characteristics, one notifying and one read-only. At least something. Now let's continue with building a client. Also here we have a ready-made example from Neil. Let's crank up this one. I take a second ESP32 development board and leave the notifying sketch running as it is. Fortunately, ESP32 boards became so cheap these days and I have enough of them from my boards test. I do not change the sketch before uploading. It starts to run and really discovers BLE devices. We see our Polar H7, a Flower care system, but unfortunately not our own newly created My ESP32 board, which is still running. Not as expected. A next secret sauce is needed. This one took me quite a while to discover. My ESP32 is still connected to the smartphone. And this seems to be like a good marriage. The guy is no more on the market to be discovered, even not on Tinder. Only if we divorce the two, it appears on the market. And we should be able to connect to it. But how can we connect to the device without the connect button of the smartphone? If we look at the sketch, we again see two UUIDs. One for a service and one for a characteristic. If we copy the two UUIDs of our server script to our client script, it scans and connects. But not to the ESP32, but to the Polar H7. Why that? This one is simple. Because the Polar also announces itself as a heart rate service. It is good enough for the girls our newly built client goes with. And it connects. Maybe the Polar is prettier than the My ESP32? Who knows? Anyway, the client connects there and not to our My ESP. How can we make that our client connects to My ESP instead of the Polar? This, once again, should be easy. Hide the prettier one and the wonder should happen. Why should? Because it happened yesterday when I prepared everything. Today I tried many things and was not successful anymore. Is it my mistake or are there some instabilities? I don't know. Maybe you are lucky and it works. Unfortunately, I do not know enough about Bluetooth Low Energy that I really can debug it to the bones. So what happens with the nice additional gadgets like the cute tag, which would serve as a remote button and starts to beep if the signal is lost, or the Xiaomi Flower monitor? All these devices have to wait on the shelf until I understand more about BLE or till the library examples get to a stage where a guy like me can use them. I'm sure all I learned so far will be helpful then. So no wasted time. Essential for an old guy like me. Anyway, we achieved at least something. We covered the basics of BLE and the roles of the devices. We used our smartphone to debug BLE and learned how beautiful the free NRF Connect works. We built a notifier which worked with the smartphone and behaved like a heart rate monitor. We created a client who found devices and connected to them, at least to the simple ones. Unfortunately, we were not able to emulate the full BLE of the Polar H7. The watch at least did not like our fake. And all our other gadgets like the iTag key finder or the Xiaomi Flower care system have to wait for better times. Still, this is much more than was possible just half a year ago, and I'm still confident that we will get BLE support for all our ESP32s shortly. Maybe not as a Christmas gift, but maybe Igor or Neil watch this video. Or you drop them a message to support them in going on with what they started. You find Neil's GitHub in the description and Igor is on Twitter. I hope this video was useful or at least interesting for you. If true, then like. Bye!